Welcome to G Fun Facts Online, the show that digs deep into the science behind our world. I'm your host, and today we're talking about something you've probably never thought about, but that affects almost everything you own, eat, and use. Look around you right now. Your phone, your t-shirt, the coffee beans that made your morning brew. Chances are, they all spent time on a massive ship, crossing an ocean to get to you. But how do these colossal vessels, some longer than the Eiffel Tower is tall, navigate the surprisingly shallow waters of our ports and coastlines? The answer is a massive, world-shaping, and surprisingly controversial engineering practice called navigational dredging. It's the hidden engine of the global economy, a constant battle against nature to keep our waterways open. But this battle comes at a cost, reshaping not just the seabed, but entire aquatic ecosystems. So today, we're going underwater to explore the incredible machinery, the high-tech science, and the delicate environmental balancing act of dredging. It's a story of brute force and surgical precision, of human ingenuity versus the relentless power of nature. Let's dive in. The main reason we need to dredge is incredibly simple: dirt, or more specifically, sediment. Rivers are constantly carrying silt, sand, and clay downstream. When this moving water reaches the calm, protected areas of a harbor or a shipping channel, it slows down, and all that sediment drops to the bottom. It's a natural process that has been happening for millennia. But for us, it means our waterways are constantly getting shallower. Without any intervention, our busiest ports would eventually clog up and become useless. Add to that the fact that our ships just keep getting bigger. The new generation of supertankers and container ships require deeper and wider channels than ever before to operate safely. This is where dredging comes in. It's essentially underwater excavation on a planetary scale. It falls into two main categories. First, there's capital dredging. Think of this as the big, ambitious construction project. It's when you dig out a brand new harbor or significantly deepen an existing channel to accommodate those new, giant ships. It's a one-time, massive undertaking. More common, however, is maintenance dredging. This is the routine upkeep, like mowing a lawn or plowing snow. It's the periodic removal of all that new sediment that's settled since the last time, just to keep the channel at its designed depth. The economic benefits are staggering. Efficient shipping means goods get to us faster and cheaper. It's the backbone of international trade. But dredging isn't just for giant cargo ships. It supports recreational boating and is vital for national defense, ensuring naval vessels can access strategic ports. So how exactly do you move a mountain of mud from the bottom of a harbor? This isn't a guy with a shovel, this is heavy engineering. The methods are broadly split into two types: mechanical and hydraulic. Mechanical dredging is exactly what it sounds like. It's the brute force approach. Imagine a giant construction excavator, but instead of being on land, it's mounted on a barge floating on the water. The most common type is the clamshell dredger. It's basically a crane that lowers a massive, two-sided bucket, the clamshell, to the seabed. The bucket clamps shut, scooping up tons of sediment, and then lifts it out to be dumped onto another barge for transport. It's perfect for working in tight spaces near docks or for removing chunky debris. Then you have the backhoe dredger, which is literally a marine-based excavator. It uses its powerful articulated arm to dig into harder, more compacted material like dense clay. It's strong and maneuverable, but it's a relatively slow process, bucket by bucket. For the really big jobs, you need to go hydraulic. Hydraulic dredging is all about suction. Think of it as the world's most powerful vacuum cleaner. These machines use massive pumps to suck up sediment from the seabed, mixing it with water to create a slurry that can be pumped through pipelines over long distances. One of the most impressive machines on the planet is the cutter suction dredger, or CSD. This is a stationary dredger held in place by giant poles called spuds that are driven into the seabed. At the front, it has a rotating cutter head. Picture a giant, terrifying blender head that chews up everything in its path. Hard-packed soil, clay, even some types of rock. As it breaks up the material, A powerful pump right behind the cutter head sucks it all up. The CSD swings back and forth in a precise arc, systematically clearing an area with incredible efficiency. These are the machines that build new land and carve out entire ports. But for maintaining the thousands of miles of existing shipping lanes, the undisputed workhorse is the Trailing Suction Hopper Dredger, or TSHD. This is a self-propelled, ocean-going ship that acts like a floating vacuum cleaner. It sails slowly over the dredging area, trailing one or two long suction pipes, called drag arms, along the bottom. The drag heads at the end of the arms collect the sediment, which is then pumped into the ship's own cargo hold, called a hopper. Once the hopper is full, the ship simply sails to a designated disposal site. There, it can either open doors in its hull to release the material, or it can pump it ashore. Sometimes, they use a technique called rainbowing, where they spray the slurry out in a high arc, often to build up beaches. It's an amazing sight. Now, all of this power would be useless and incredibly destructive without precision. Modern dredging isn't just about digging holes, it's a high-tech, surgical operation. The science that makes this possible is called hydrographic surveying. Before a single scoop of mud is moved, survey vessels map the seabed in painstaking detail. They used to do this by dropping a weighted line to measure depth. Today, they use sound. Multi-beam echo sounders send out a fan-shaped array of sound waves, creating a complete, high-resolution 3D map of the underwater terrain. It's like giving the seabed an MRI. This initial survey tells engineers exactly how much material needs to be removed and helps them choose the right equipment. During the dredging process, the dredger itself is equipped with high-precision GPS, often accurate to within a few centimeters. The operator can see the exact position of the dredge head on a screen in real time, overlaid on the 3D map. They are removing material only from the designated areas, to the exact specified depth. This isn't just for efficiency, it's the first line of defense in protecting the environment. After the job is done, a final survey confirms that the channel is clear and safe for navigation. So we have this incredible, powerful, and precise technology that keeps our global economy afloat. But here's where the story takes a turn. The very act of scraping, digging, and sucking up the seabed has profound consequences for the environment. Let's start with the most obvious impact: habitat destruction. The seabed isn't just mud and sand. It's a bustling city of life. It's home to the benthic community, worms, clams, crabs, and countless other invertebrates that form the foundation of the aquatic food web. Dredging is like taking a bulldozer to that city. It physically removes the habitat, and the recovery of these communities can be incredibly slow. Then there's the cloud. The dredging process inevitably kicks up a huge amount of sediment, creating a plume of suspended particles in the water. This cloudiness, known as turbidity, is a major problem. First, it blocks sunlight from reaching aquatic plants and seagrass beds on the bottom, stunting their growth and affecting the entire food web that depends on them. Second, high concentrations of this suspended grit can clog the gills of fish, causing them physical stress or even killing them. But perhaps the most insidious danger of dredging lies in what's buried in the mud. For centuries, our industrial harbors and urban waterways have been a dumping ground for pollutants. Heavy metals from industry, toxic chemicals like PCBs, and pesticides from agricultural runoff all settle on the bottom and get buried in the sediment. In the oxygen-poor layers of mud, these contaminants can lie dormant for decades. Dredging is like opening Pandora's box. It stirs up these old, contaminated sediments and re-releases them into the water. When anoxic mud hits oxygenated water, the chemical change can cause these toxins to detach from the sediment particles and dissolve into the water. In this dissolved state, they are much more bioavailable, meaning they can be easily absorbed by plankton and small organisms. This is how toxins enter the food web. They bioaccumulate, becoming more concentrated as they move up from small fish to larger fish, to marine mammals, and potentially to us. Recognizing these huge challenges, the science of dredging is now just as much about environmental protection as it is about engineering. The goal is to find a balance. One of the most effective strategies is creating environmental windows. This means scheduling dredging operations to avoid sensitive biological periods, like fish spawning seasons or the nesting periods of coastal birds. To control those underwater dust clouds, dredgers can deploy silt curtains. These are essentially giant underwater fences that hang down from the surface, containing the sediment plume and allowing the particles to settle in a confined area instead of drifting off to smother sensitive habitats. But the most exciting development is the shift in thinking about the dredged material itself. For a long time, it was just considered waste to be dumped somewhere else, hopefully out of the way. Now, there's a growing movement to see it as a valuable resource. This is called beneficial use. If the dredged sediment is clean, it can be used for incredible environmental projects. Sand dredged from a shipping channel can be used for beach nourishment, replenishing eroding coastlines, and protecting coastal communities from storms. Mud and silt can be used to build and restore critical habitats like wetlands and salt marshes. These marshes are vital nursery grounds for fish and provide a natural defense against sea level rise. Clean material can even be used to create new islands, specifically designed as nesting sanctuaries for seabirds. And in a clever twist, clean dredged material can even be used to help solve the contaminant problem. It can be carefully placed over the top of existing contaminated hotspots on the seabed, creating a cap that isolates the pollutants and prevents them from ever re-entering the environment. So where does this leave us? Navigational dredging is an unavoidable reality of our modern, interconnected world. The engineering that makes it possible is nothing short of spectacular, a testament to our ability to reshape the planet. But that power comes with immense responsibility. The future of dredging is a continuous voyage, navigating the complex currents between economic necessity and environmental stewardship. It will be defined by smarter, greener, and even autonomous machines guided by real-time data to minimize their footprint. It will be driven by a deeper understanding of our aquatic ecosystems and a commitment to turning what was once a problem into a solution, using the very material we remove to heal and restore our coastlines. It's a powerful reminder that for every action we take to build our world, we must also consider the natural world we're building it in. Thanks for listening to G Fun Facts Online. Join us next time as we uncover another fascinating piece of the world around us.